This is geometry. Chapter 8, lesson 3, page 312. Okay, so the tables on the top of page 312, they are very interesting looking. They do not look the same. Many of you said it looked like a dilation. In fact, they are the exact same. They've just been rotated. That's correct. So when the original image is exactly like the image of it after a transformation has happened, what do we call that? We call that it was a new word. Starts with a what? What? Isometry. Right? When the original figure matches the transformed figure, whatever transformation that is, we have an isometry. What does an isometry do? Yes?
It's when there's some kind of transformation, but it maintains distance and angle.
It maintains every distance and every angle. So every length stays the same, every angle stays the same. So when we have a transformation and the image is isometric to the original, then the original and the image are congruent figures, right? Do you see how isometry and congruence can go together? Do you see that? Well, they do. They go together. So look at the bottom of page 312. Two figures are congruent only if there's an isometry such that one figure is the exact image of the other. So if I know that the transformation is an isometry, then I know that the figures are congruent. So isometry really sort of describes the transformation. Congruence relates the two items, the original and the image. Make sense? All right, so it is this transformation on the top of the page, those tables, even though it looks like a dilation, the two figures are in fact congruent, and if they're congruent, the transformation is isometric. Does that make sense? How the two go hand in hand, sort of? Okay, so now there's a new type of transformation. It's called a glide reflection. Yes?
No.
You sure? A glide reflection. What does the word composite mean? Remember we talked about that? Composite. Remember we had composite reflections through parallel lines. Remember we did this? A to B is a reflection. B to C is a reflection. So A to C is a translation. So a composition of two reflections through parallel lines is a translation. Yeah. So what is composite? What do I mean by composite then? More than one. Thank you. More than one. Composite. Sort of like conjunction. More than one. I'm two types of translations. It's composite. Got it? So a guide reflection is multiple transformations, okay? But what is it? First, it's a composite of a translation and a reflection in a line parallel to the direction of the translation. All right, look at the image on the right. All right, it's as though we have this with the feet, right? So it's A to C. So it's two reflections across parallel lines. And then what happens here? Then it's reflected across a line that's not parallel. So we have a translation and then a reflection. It's like the feet. This is sort of easier to see than the feet. Such that A to B is a reflection, B to C is a reflection, C to D is a reflection, but A to C is a translation and C to D is a reflection, but A to D is a glide reflection. Do you see how we've added one more? So A to D is a glide reflection, right? Get it? So I glide, then I reflect. Although I can't reflect myself, unless there's a mirror, right? Makes sense? A to D is that concept of a glide reflection. It's a composition of two reflections through parallel lines, and then it reflects over a perpendicular line. So really it's three reflections, right? Or it's a translation and then a reflection. Does that make sense? That's the only new transformation. Are these an isometry? Yes. Is A congruent to D? Yes. So a glide reflection is an isometric transformation, and the image is congruent to the original. Okay? It is a mirror image. So how many reflections require a glide reflection? 1, 2, 3. So 3 reflections are a translation and a reflection. You see that?